welcome again, Wildcats. Today we're looking at Wednesday, January 10th, imaginary numbers and complex numbers on page 43. So if you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. All right, so we're looking at imaginary numbers and complex numbers on page 43. An imaginary number is a number that is expressed in terms of the square root of a negative number. So I equals the square root of -1. Now, what we need to do from here is understand what I squared is. Okay, so we know I is square root of -1. Because there's an equal sign, we can do whatever we want to as long as we do it to both sides. So in this case, we're going to square both sides. Okay, again, our goal is because we want to know what I squared is. Well, we square both sides, we have I squared. When we square square root, this goes away. So we're left just with -1. So we can see that I squared is -1. So the two important concepts about imaginary numbers is you need to know that I is the square root of -1 and I squared is -1. Okay? All right, so if you would finish up your imaginary number notes. All right, now let's take a look at complex. All right, complex number is a number that can be expressed in the form of a plus bi, where a and b are real numbers, and I equals the square root of -1. Every complex number has a real part a and an imaginary part b. So a is the real part, and b, I is the imaginary part. So if you would, update your complex number notes. All right, now your notes are updated. Let's take a look at the examples. All right, starting off, we're going to graph complex numbers, okay? And so remember, we know it's in the form of a plus bi. Okay, so we can write 2 as 2 plus 0i. So when we graph, we go over 2, but there's no imaginary, so we don't go up or down, so it's just a point at 2. So that's point A. Okay, -3i can be written as 0 minus 3i. So we don't go left or right on real, we just go down 3i, and that is point B. All right, and so then 2 plus 4i, we go to the right 2, up 4, and that's point C. You might pause the video for a moment and try to graph D and E on your own. All right, at this point, I'm assuming you try D and E on your own, so let's do it together. So then we go left 4, up 5, and that's point D. And then E, we go to the right 2, down 3, and that's point E. All right, so that's how to graph complex numbers. All right, so now let's move on to example 2. Simplify the expression. Now, here we have parentheses, but really there's just ones in front of the parentheses, and when you multiply 1, you get the number itself. So really, we don't need the parentheses, or we can just ignore them. Okay, so I'm just going to ignore them. And so then you combine like terms. So I'm going to combine the -2 and 3. And then we're going to combine the 4i and the -11i. So -2 plus 3 is 1. And then 4 minus 11i is -7. I. And remember, whenever you're writing simplified expression, it needs to be in the form of a plus bi. And so we have a and bi, so that is correct. All right, so now let's take a look at example 3. So again, there's a 1 in front of here, so we can ignore the parentheses because we're just multiplying by 1. But here, we're multiplying by -1, so we need to distribute the -1 before we combine like terms. So here we have 4 minus 1i. We distribute the -1, so we get -5 minus 8i. So we really don't have to put the numbers next to each other like we did here. We can just understand that here we have 4 minus 5, which is -1. And then we have -1i minus 8i, which is minus 9i. Again, we have it in the form of a and bi, so we are done. All right, now let's take a look. And in fact, actually, now would be a good time to pause the video and try example 4 and 5 on your own. And remember, at any time, if you're having trouble or didn't understand any examples, just circle that example, and then in class, I'll go over that example with you, okay? All right, example 4. So again, here we're just multiplying by 1, so we can ignore the parentheses. So we have 10 plus 3i. But here we have to multiply or distribute by -1. So -1 times 10 is -10. And -1 times -4 is a positive 4i. So 10 minus 10 is 0. And then 3 plus 4i is 7i. And again, I wrote the 0 because we always want to write it in a and bi. So we have a is 0 and b is 7. All right, example 5. So again, here we're just multiplying by 1, so we can ignore the parentheses. So we just combine terms. We have 6 minus 6 is 0. And -2i plus 2i is 0. So we have 0 plus 0i. All right, so now let's take a look at example 6. All right, simplify the expression. Parentheses mean multiplication, so we're going to multiply. So -6 times 5 is -30. I times I is I squared. But remember, I squared is equivalent to -1 from our notes. So that is -30 times -1, which equals 30. Now, I would accept 30 on example 6, but I'd also accept 30 plus 0i. All right, example 7. Here, parentheses mean multiplication, so we're going to multiply 2i times 3 and -5i. So 2i times 3 is 6i. And then 2 times -5 is -10. And then I times I is I squared. So then that's 6i minus 10 times -1. And I'm going to rewrite this because remember a plus bi. And so -10 and 10 is positive 10 plus 6i. All right, example 8. And actually at this point, you probably want to try to finish example 8, 9, 10, 11 on your own and then click back onto the video and just to watch so you can verify if you've done it correctly. All right, example 8. But again, remember, at any time, if there's a question, you get stuck on a problem, remember, you can circle that question, and I'll go over that in class, okay? All right, so -2i times 2 is -4i. Now, -2 times 4 is a positive 8. I times I is I squared. So then you have negative 4i plus 8 times negative 1. I'm going to rewrite it so that the a is in front, so that's negative 8 minus 4i. All right, example 9. Now here you're multiplying 2 here. So it really just comes down to just like you did before with the box method. So then that's 5 minus 6i times 4 minus 3i. So 4 times 5 is 20. 4 times negative 6 is negative 24. Negative 3i times 5 is negative 15i. And then negative 3 times negative 6 is 18. And I times I is I squared. So you have 20 minus 15i minus 24i plus 18i squared. So then you combine like terms. So then that's 20 minus 39 I, and then I squared is negative 1, so that's plus 18 times negative 1. So then that's 20 minus 39i minus 18. 20 minus 18 is 2 minus 39i. So I apologize, I cut the screen off, so I'll just say that again. So basically what happened here is 18 times negative 1 is negative 18. And then you combine terms. So 20 minus 18 is 2. And then you just minus 39i. All right, so let's look at example 10. Again, we're going to multiply using the box method. So 7 plus 2i, 7 minus 2i. 7 times 7 is 49. 7 times 2 is 14i. Negative 2i times 7 is negative 14i. Negative 2 times negative 2 is negative 4. I times I is I squared. So then that equals 49. And really, you don't have to write this step where we wrote those. You can just do it here. You can combine terms. Negative 14i plus 14i is 0i. And then minus 4, I squared is negative 1. So then negative 4 times negative 1 is a positive 4. Add 4 to 49 is 53 plus 0i. So I've kind of showed you an example 9 and 10. This is acceptable steps, but if you want to show all your steps, it would look like that. All right, example 11. Again, multiplying using the box. So 4 minus 4i times 6 minus I. So 6 times 4 is 24. 6 times negative 4 is negative 24i. I times negative 4 is negative 4i. Negative times 4 is a positive 4. I times I is I squared. So you have 24. Again, you can combine terms here, so that's negative 28i. And then plus 4 times I squared, which is negative 1. So then you have 20, well, we can combine terms here. So that's technically negative 4. So 24 minus 4 is 20. And then minus 20i. All right. Well, I hope you enjoyed this imaginary lesson. And at this point, you have two options you can go. If you understood the examples, I would start working on the assignment. If you had questions on the examples, your other option would be to circle the ones you had questions about, ask me about those in class, and then start the assignment in class. Either way, have a wonderful Wildcat day. Okay, Wildcats.